Wow. Hey guys. Good morning. How's everybody doing? Yeah, good. Start of a couple of intense days, right? My name's Mark Linesch. I'm the Vice President of Technology Strategy for our Chief Technology Office and HP Labs, or Hewlett Packard Labs. I report to the Chief Technology Officer and Head of Labs, who then reports to Antonio Neri. And Chris has asked me to come in and just kind of frame out a little bit, some of our thinking here as we continue to, really drive the new Hewlett Packard enterprise. And as I think Chris indicated, I have a fairly large, broad remit. In other words, I get involved with a lot of really talented researchers and engineers looking at the future, looking at our innovation strategies across the different organizational structures that we have within HPE. So I'm not, I'm not of any one tribe, I guess you'd say. I'm cross-cutting across the company, knitting together strategies that we think are important for our future health, success in the marketplace. And so I've got some slides, but let's make this really interactive. And everybody ready to get started? Yeah? Okay. A little transition to this digital enterprise, right? So I think as you guys realize, technology continues to kind of move in waves, right? And when I started in computing, it was all about systems of record, recording history and transactions and things like this. And the software stacks associated with that were clearly mainframes and mini computers and the emergence of Oracle and the database world. And then we took a move to client server in the internet days, systems of engagement, moving outside the organizations, engaging with customers and partners, to the mobile cloud environment that we now find ourselves in, where we're thinking now of experience, everything as a service, everything as a mobile experience, everything as a location-specific mobile experience. And we're moving now toward kind of doubling down on that kind of mobile cloud experience with this notion of edge to cloud. The notion that we're injecting all of our people and things and places with intelligence, with interactions, with the data that's associated with that. And we call that era the systems of action, right? And so it's not like we're not just moving on. We're building on many years of history and many years of success with IT. And of course, the apps and the data is very different in today's world than in the past. A lot of my background in the early days was in artificial intelligence, back in the 80s with rule-based systems, natural language expert systems. And back then, neural nets were, invented and kind of very interesting kind of technology, but they weren't very useful because of two things. We didn't have the performance of today's systems to do the training, and we didn't have the data and the data sets, the huge data sets that were required to do that training. Now we have cat videos. We have lots of cat videos, and so we can start to do lots of interesting training on cats and dogs and trains and planes and automobiles and predictive maintenance and all kinds of things. Now, we got together about a year ago as a chief technology ecosystem, if you will, across the company, and started to say, well, what's this future look like, and the future of Hewlett Packard Enterprise look like? And we came to an agreement literally in about 2 hours. Now think about this, there's probably 15 chief technologists in the room from all the different business units across Hewlett Packard Enterprise. And we actually came to agreement in 2 hours with the following 6 statements, right? Number one, we're really accelerating toward this more secure, intelligent, autonomic as-a-service experience. If you ask me, do I want to go back to the old days of installing, ordering, installing, configuring, handcrafting bespoke systems for bespoke applications and all of the different work that's done to stand this stuff up and move it around, I'd say absolutely not. In fact, in my life, I expect all of my interactions to be more kind of in this as-a-service experience. And data really is the new intellectual capital, right? It's the thing that is driving this new era of systems of action and insight. Intelligence is going to be injected in all of the applications, all of the tooling, all of the people and places and things that we're digitizing around the world. And that, of course, requires us to think very differently about security. If you look at our Aruba organization, for instance, they're using machine learning to secure the network, and then they're using behavioral analytics and machine learning to figure out whether or not you should have access to the network, and if you have access to the network, what part of the network, and then as you transverse that network, is the behavior that you're exhibiting good behavior, or do they need to take policy and blacklist you from particular access to particular things? So we're redefining the way we think about this, and the edge, and this edge to cloud dance that we're increasingly doing is really having us rethink security in a big way. It's also, of course, having us accelerate this notion of as-a-service and consumption-based pricing, right? The notion of who doesn't like paying for just what you utilize. And so as we went down this list and we talked about these things, part of the question for us was how far along are we on some of these core technology tenets, right? How far are we invested and injecting these tenets into our product, our services, our solution strategies as we sort of move along. And what I'd like to basically articulate to you guys is that we're pretty far along. A lot of people think of Hewlett Packard Enterprise as, well, you guys are a software-defined infrastructure company. Great, okay, all right. And we manage that software-defined infrastructure from the edge of the network, the things, the people, the places, through the hybrid cloud environment that includes public, private, traditional data center environments. And we do that very well. We probably do that better than just about anybody else in the world right now, okay? But increasingly, as we paper the industry with new digital technologies, we're going to have to do that in a much more autonomous way, in a much more automatic way, in a much more intelligent and secure way. And so injecting these capabilities into this future enterprise is kind of critical. And that future enterprise is always hyper-connected at the edge. We're gonna take connectivity as not just something that we'd like, but something that is almost a birthright. My kids are like that. When they can't connect to the internet, they start to get nervous. When email goes down, which is a very, very rare experience in our sites, many people kind of look around and they say, well, I guess I better go home. What am I going to do, right? What am I going to do? So connectivity in every place, from that plane, through the car, through the building, through the shopping center, is going to be ubiquitous. And you guys realize that. Now that takes a certain level of security, trust, and control. So you see the rise of things like blockchain, right? We're doing work today on what we call mission critical ledger technology, right? For supply chains, for IoT, and for these kinds of things. Because people in a big data world want to know the provenance of that data. They want to know the provenance of things. And so in these huge supply chains, they want to know that this component came from there, and this component came from there, and it got assembled over here, and then it went through the transition over here, and it went to final assembly over here. And they want to be able, from a quality perspective, from a security perspective, to be able to track that provenance and to do so in a highly efficient way. And so things like blockchain are important. Control is important from that very edge of the network, whether that's an autonomous vehicle or whether that's a smart city. They want to be able to control, okay, that interaction between those edge devices and what we're back doing at the data center or the cloud. Yeah, absolutely.
You mentioned Mike. Yep.
Yeah, Mike.
Where's Magic Carbide? Down there. There we go. Cool. So you mentioned some of the stuff that Aruba is doing with fingerprinting and analyzing the traffic that's coming in. There's two sides to the house, right, within HP. Is some of that going to start to make its way into data center with what you guys are looking at? And if so, I mean, what does that look like? Understanding how to do that security fingerprinting, the RASA stuff, understanding, analyzing packets, kind of conforming them into what they're supposed to be doing, why they're supposed to be doing it, when they're supposed to be doing it. What does that look like from the HPE side? Is that something that Aruba will make a transition into, or is that something that HP is developing something much more massive?
Yeah, great question. I think from a security perspective, Labs has what we call a security lab, right? And it's headed by a gentleman by the name of Gary Campbell. And the way that we run security at HPE is a horizontal function, okay? And then a kind of a segment-specific thing. So our labs organization has a core team that's made up of Aruba technologists, hybrid IT technologists, point next technologists, and they're crafting our overall kind of security strategies for the corporation, okay? And those involve combinations of Aruba technology like the behavioral analytics, introspect, and those kinds of things, with some of the things that you would recognize in the hybrid IT space, like root of trust capabilities and these types of things. And so the way that we think about it is I've got to be able to secure from a root of trust, a hardware root of trust, all the way from the firmware and BIOS through the operating system, all the way up through the application, okay? And from a network perspective, from the edge to the core, okay? And I have to be able to do that in an intelligent way because people aren't very good at sussing out those patterns, right? And so it's there's so much data. And so it's a combination of the technologies associated with our platform teams, with our services and solution teams, our Aruba teams. And then what you see happening out of that broader strategy is specific implementations that get done on ProLiant, Gen 10, or on Aruba and those types of things. And so just to succinctly answer your question, yes, indeed, you will see a flow of some of these security ideas because we're all working on security as a top-level critical area for Hewlett Packard Enterprise.
And in the slide, got to be smarter than the microphone, right? Yeah. So in the slide that you showed, was that? I know that they were numbered, but it wasn't specific if they were hierarchical. Like, is it? I mean, security relies on, that slide that showed the stack of what you guys agreed on. Mm-hmm. It seems like security is you definitely taking a high interest in security above much other things. And is that kind of how that falls in there?
I don't know that when we wrote that slide that we were thinking that one was more important than another, but that those 6 things were incredibly important technology tenets, if you will, right? Guiding principles, if you will, for how we think then about evolving our portfolios, our technologies, and what's really important for us to focus on, okay? Yeah. Okay. And I guess the last one I'll just mention is this notion of composition, right? You guys have all had a healthy dose of synergy and these kinds of things, right? What's interesting to me is that the industry is now moving toward where we've been for the last couple of years. They're moving more toward a memory-driven computing kind of architecture. They're moving more toward now starting to talk about composability. 2 years ago, Dell said composability, what a bunch of yoo-ha. Last month, composability was top of the pops for their annual thing. Why is that? Why is that? Because Dell, IBM, all of our different competitors, the entire industry is now starting to say, well, wait a minute. We are reaching the limits of Moore's Law. We do need to think about what's our next generation of architecture, and that next generation of architecture is data-driven, right? It is composable, and it is highly secure and highly automated, injected with machine intelligence and these kinds of things. And so what we're seeing, I think, is the industry kind of waking up to the fact that we're in a time of enormous change, enormous technology change, enormous business model change, and that, you know, quite frankly, we're all learning, we're all trying to figure out then how to manage and take advantage of that change in our own business lives. Our customers are all thinking about that. I was at Ford Motor Company for a day, I don't know, probably a month ago. I was in Germany 2 weeks ago talking to the automotive manufacturers. The automotive manufacturers are racing to autonomous vehicles. They're making billion-dollar bets on the edge of their network, which is the automotive vehicle and the fleets of automotive vehicles that are interacting with a smart city and that are ingesting huge amounts of analog data and turning that into action at that edge, right? And so that story of edge, core, intelligence, autonomic interactions is playing out in every industry, automotive industry just being one, and it completely changes their business model, completely changes their business model. Less personal drivers, more fleets, more Uberized types of interactions, more data, more insights, new services that they can provide as they collect and analyze that data. And so, you know, when we said our strategy is powering this intelligent edge and looking at that hybrid core and the interaction of those two across data and applications, I think we've proven to be fairly precedent in our strategic statements here, right? And we've been working on this for years, quite frankly. And so what's fun for us is that we have an innovation agenda within HP and a portfolio that is really starting to click with our customers, okay? It's an innovation agenda that is edge-centric because, as Gartner has said, about 75% of all processing of data is going to be at that intelligent edge. It's very data-driven, and the data that we're using now as we move from programming to training and learning is enormous, and it's all cloud-enabled. It's all as-a-service enabled, right? Whether it's in a public, whether it's in a private, whether it's at the core, whether it's at the edge. It is all this notion of how do I deliver a great experience, an autonomic, intelligent, secure experience, and deliver the outcomes that our customers need. And so, yeah, we're investing in cloud and automation and security. We're investing in engagements with developers because developers are really leading the charge in this sort of new wave of applications and insights. Investing in AI and software-defined infrastructure, IoT, and consumption. Now, most people think of, oh, Hewlett Packard Enterprise, we're software-defined infrastructure. That's true. We make great software-defined infrastructure. But we're much, much, much more because our customers are demanding much, much, much more as they digitize their worlds, their businesses in relationship to their competition. A little reminder on innovation for all you guys, in that we think of innovation in kind of three interlocking circles, right? We do a lot of organic innovation. The machine research is an example of long-term research on photonics, on fabrics, on memory, on exascale systems and the like. But we also do a significant amount of M&A, 11 different acquisitions over the last year. Partnerships are also very, very important. In fact, partnerships are critical. How many folks are in the IoT space and actively looking at some of the edge stuff today? Just raise your hand, right? One of the most striking things about IoT today, or the intelligent edge, is the amount of partnerships required between operational technology and IT technology to deliver that business outcome, right? It's not, it's not HP kind of doing it all themselves, or IBM doing it all themselves, or Cisco doing it all themselves. You've really got to think deeply about how do I partner with an industrial, interface? How do I inject that into my computational environments? How do I manage the data from edge to core? How do I do a whole bunch of things that require new skills, new capabilities, new partnerships to be established? And when we think about our innovation pipeline, we think about long-term research, but quite frankly, the industry is moving toward bringing that in a little bit into a more practical frame. So we still do some long-term research on optical computing and on some of next-generation acceleration and things like that. But increasingly, we're looking for a faster transfer of our technology into an advanced development where we're doing proof of concepts with customers, we're doing sandboxes, and driving that into our product portfolio. And so this is a very exciting time for us because we're starting to see the fruits of some of our efforts. Now, this is a slide that I use with the industry analysts to talk about what we're doing in labs, right? And we're working on next generation wireless. Next generation wireless is going to be huge, right? 5G is going to be an enormous wave. And then how do you integrate the experience of Wi-Fi and 5G so that it's seamless? And as I walk around, run around, go from place to place, I can connect automatically to the right networks without ever dropping a line and with ever interrupting my experience, right? How do I do intent-based security and profiling, right? And how do I do more than just location services, really extend that to context and environment and these types of things? How do we do edge to core management? Today, what you see from our customers is they say, I want to put an edge line in a factory. I've got 50 factories around the world, okay? And I want to hook that into an operational OT environment. One of the use cases that we're seeing is one of our customers looking at how do I use video analytics and machine learning to spot defects in silicon wafers as they come down the line, be able to characterize that defect, be able then to remediate that issue and take an action right there at the edge, right? Now they've got like 40 factories around the world, but they don't want to do this in a traditional way. They want to deliver edge as a service. And so they want a complete managed service for being able to set it up, configure it, provision the software stacks, update the firmware, the software, and all that kind of stuff. And they want that to be a total as a service experience, right? And those are the kinds of customer challenges that we love because they push us in a direction that really combines the best of Hewlett Packard Enterprise and our partners, right? We're not Amazon, we're not Azure, and we're not trying to be, quite frankly. But that doesn't mean that we can't inject as a service experience, consumption-based modeling, and these types of things, managed service capabilities into our core offerings because that's what the customers demand. And as we move further into this distributed systems area, technologies like blockchain, technologies like mesh computing are becoming more and more important. We're doing quite a bit of work in blockchain with customers today on supply chain and on different aspects of banking and the like. Pretty exciting stuff. We're seeing a real move toward in-memory computing today, fabric-attached computing tomorrow. We just announced in December our Superdome Flex, and we're announcing here memory-driven computing personality on our Super dome flex machines. And so real-time analytics is becoming very important, not just with SAP HANA, but with Oracle and other proponents like that. How many people believe that the Moore's Law is reaching its limits and we're struggling to figure out what's next? Anybody not believe that? Okay. So then the question is, well, how come NVIDIA's stock price is so high, right? Anybody know? Yeah. It's because we're using much more floating point, much more acceleration and special task-specific processors as we enter into this new phase of more intelligent, more machine learning, more driven types of applications, right? And so you're going to start to see the limits of kind of general purpose integer processing. We're already seeing that with the many cores that are unbalanced with regard to memory and the limits of being able to eke out the performance that we're looking for. And so the industry's turning to accelerators, FPGAs, GPGPUs, new types of environments. When I was in Germany last week, one of the technologies that we have is a analog to digital accelerator that has the characteristics of very low power, very low power. And the automotive guys, their eyes were wide open. They're like, that's exactly what we need, right? Because right now they're testing these vehicles with standard integer processors, GPGPUs, but they realize that they're having to put a fairly significant amount of computation in a car, right? And they're going to need to really, really deal with the power envelope, the fit, if you will. And when we look at these edge devices, this is becoming very important. It not only has to perform and do analytics at the edge and potentially take an action, but it has to be very low power and it has to fit into the form factor that you're thinking about here. So deep learning is becoming a critical area for all companies in a huge race to figure out how to utilize deep learning for particular companies' advantage. Now, we're not going to be trying to compete with a Google or an Amazon and create our own deep learning frameworks, but what we can do is create a cookbook that allows us to guide a customer or a partner. Oh, you want to do video analytics? Well, here's the framework that you ought to go use, and then here's the configuration of the Apollo machines that you ought to use to train that. And then from an inferencing perspective, here's the configuration of an edge line with an accelerator that allow you to do that inferencing at the edge. And so we can help these customers in those kinds of areas. Long term, we're still working on memristor-driven and other brain-inspired types of technologies called neuromorphic computing, and those will pop out at the appropriate time. But we're learning so much about how to really sort of drive these next generation architectures, these task-specific processors, that we're going to see some pretty exciting things. And a lot of that foundation, and you guys probably don't realize this, is that we have a world-class VLSI team, okay? And a lot of that work is funded by the government, by government entities that we really can't talk a lot about, but they're fundamentally looking at these next generation architectures and saying, how do I build these next generation exascale architectures where I can address every point of memory on a fabric and really analyze petabytes and petabytes of data, right? We have a program called Path Forward with the DOE that I can mention because there's a press release about it, which is about building a next generation exascale system based on memory-driven computing. And our VLSI capabilities are a big foundational element there. Yes, sir.
Traditionally, you guys have worked with even some of your silicon partners on future processing architectures and stuff like that. With deep learning and machine learning right now, even your traditional silicon partners are working on custom accelerators. Is HPE involved in some of that development on some of those accelerators for specific applications?
Yes, we are. And in fact, we have some of our own technology. We're working pretty specifically with NVIDIA, with AMD, with Intel, to name a few. That and you know, all of those organizations are looking to how do we take these task-specific processors, integrate them into the software stacks, into the application stacks. How do we create these next-generation systems? So that's a big part of what we do. And we're not trying to say that our accelerators are better than their accelerators, or that this, that, or the other thing, because quite frankly, I think what you'll see is a range of you know, kind of data center level acceleration. You'll see a range of edge acceleration, okay? But what we're doing is basically working from an industry standard perspective. So anything that we do is going to be based on the industry standard frameworks of TensorFlow and other things like that. Great question. Another area that we're working on with semiconductor manufacturers across the board is, of course, memory semantic fabrics, right? You know, in order to unlock memory from a CPU so that you can address a petabyte of memory and actually pool that memory and assign it to specific nodes, which is at the heart of memory-driven computing, you need a fabric. Now, we have a fabric. We have a very high-performance fabric in our Superdome X and Superdome Flex environments, but we decided 3 or 4 years ago that memory-driven computing wasn't just a HPE thing, it needed to be an industry thing. So we helped establish the Gen Z Consortium. It has 55 members today, including some new members that have just joined. Cisco just joined. You know, we've got all the different system vendors and all the different silicon vendors and memory vendors and the like, because what they see is this big data, intelligent environment coming down the track and saying, well, look, locking memory behind a CPU is no longer the right architecture. We need to pool memory. We need to compose memory. We need to pool and compose GPUs. Today, if you think about the standard compute environment, it's a 2-proc box with memory locked behind the CPU. So now I've got to move data all around those clusters and all around those areas using high performance InfiniBand and all kinds of wonderful things like that. Great, but moving data costs a lot of overhead in terms of energy, and in terms of programming, and in terms of just raw performance and power. So let's flip the switch. Instead of moving data to the compute, let's move the compute to the data. Let's have a big pool of memory, a big pool of GPUs, and then let's assign an integer processor or a GPU processor or both, or a pool of those things to the task at hand. And that's what memory-driven computing promises, and that's actually what we're in the process of delivering. And that takes new VLSI, new systems architectures, new software, new ecosystem, and the like. Gen Z, some of the work we're doing with the open source community is all designed to lay the foundation, lay the track for this next generation of highly intelligent and secure computing. So I will focus on just 3 things. Yes, go ahead.
Just on that, I was going to ask you what you think of some of the other startups out there working on accelerators, in-memory accelerations like GraphCore and stuff like that.
You know, I think it's always great, quite frankly, to see this kind of thing. 2 or 3 years ago, we just got a load of criticism about our memory-driven computing vision. It was like, oh, the machine, you know, blah, 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 right? Now, what's happening? The industry is moving in this particular, you can see evidence of that in acceleration, in terms of composability, and in terms of these other kinds of things. So our attitude is bring it on, right? And if some of those startups have some really interesting technology, we'd love to engage with them, right? So I want to highlight kind of 3 things, right? This slide is a weird slide. It starts over here with these S-curves, right? And 4 of my favorite S-curves that are all happening at once, which is somewhat unique from a technology perspective, is we're moving from compute to memory-centric architectures. We're moving from analytics to AI. We're moving from as a product to as a service, and we're moving from mobile to edge to cloud. And we're doing that all at once, right? And these things are interlocking. They're related to each other. And so when you derive out of these changing technology landscapes, three core elements. One, customers are struggling with the right mix of private, public, traditional, and they need help to kind of navigate that. And they need help managing that and securing that and making sure that that mix delivers the right competitive advantage and outcomes for them. So how do I simplify on-premise? How do I simplify multi-cloud with products like OneView or like OneSphere or Aruba Cloud Platform? How do I do that in a world where everything and everybody is computing, right? And where we have this intelligent edge. That edge can be an automobile, it can be a smart building, it can be a street lamp, it can be a whole lot of different things. And that core, which could be a private cloud, public cloud, or the like, how do I manage the security across that? How do I manage the data across that? How do I manage the control aspects? And then, of course, as data becomes the center of our universe, and not just data, but the insights that are derived from that data, how do we think about these new architectures that are open, that scale, that allow us to compose not just compute and storage and fabric, but also memory and acceleration, so that I can say, well, look, I've got 100 terabytes of memory. It's on a fabric. I think I'll assign 10 terabytes to this node, 20 terabytes to that node, 25 to this node. Oh, I changed my mind. I think I'll do something different here, and do that in an automatic way. How do I optimize these memory-centric and data-centric programming tools that we're going to need? If I'm keeping my data and my algorithm in hot memory, I'm no longer shuffling between hot and cold. I'm saving a lot of programming steps, I'm saving a lot of energy, and I'm dramatically increasing my performance. And we think about memory-driven computing as something that is a natural as these storage class memories come into focus, and we're able to do load store operations on huge amounts of main memory, on storage class memory, up to about 300 nanosecond load store time, okay? So that all of a sudden, I can start to think about real time and these types of things. And acceleration, task-specific processing is going to be a big part of that, supported by an as-a-service consumption model and delivered via some of these services. And so, you know, you guys are going to get a dose of OneSphere and OneView and Green Lake and our CTP team. Those are not separate, you know, thoughts. Those are a well thought out, integrated strategy for how do we simplify and really deliver on the promise of a hybrid cloud and a hybrid IT environment. Yes, sir.
Yeah. Can you, going back to the memory discussion, I didn't hear you touch on it, which was more permanent, long storage, low latency memory, like what you guys wrote in the past in MEMSistor or 3D Crosspoint. How does that fit in that overall vision of memory-based computing?
The industry calls that storage class memory. 3D Crosspoint's an example of that, but if you talk to Micron or Samsung or some of the other memory players, they're all kind of working in that particular area. Storage class memory, as you rightfully said, can also include memristor. It can include additional types of technologies. And this technology is starting to ripen. It's starting to mature. We'll see Intel's storage class memory, coming into its first maturity stage here pretty soon. And for instance, with our Superdome Flex, we've got the opportunity to utilize that storage class memory and potentially utilize it on a fabric. And so you can have both DRAM and you can have storage class memory all doing load store operations, right? All keeping data and algorithms hot, eliminating your shuffle between your hot and your cold, increasing your overall performance, lowering your power envelopes and these kinds of things. And these are the types of systems that we're engaging with the federal government on right now in high performance computing, and then the types of systems that we're conceptualizing for introduction over the next few years. And so storage class memory or 3D cross-point kinds of memory devices are going to be very important. You're going to see, I think, what you think of as memory tiering, right? You're going to see on-chip memory, you're going to see DRAM, and you're going to see storage class. But all three have the characteristic that I can run read-write, load store kinds of operations and keep that data hot without having to shuffle it out to checkpoint or log files or other things like that into a persistent, you know, kind of classical storage like flash or disk. Make sense?
Hey, Mark.
Yeah.
Question for you. So we're at a technology show. You're in a room full of technologists. They want to hear about our tech, which is all great. But what we forget about is tech's run by people.
Right.
And everything we do here is essentially changing people process. Can you talk a little bit more about that? We've got CTP up here and you've got GreenLake up here. It might be a good point to start talking about tech is great, but it's all about people.
Yeah, that's a good point. I think the reason why CTP and GreenLake are up here is precisely that point, is that our customers love tech. You guys in this room love tech, okay? I love tech, but if you can't figure out then how to combine that tech and deliver that tech to deliver a business outcome that the customers are really looking for, you got a real problem. And what customers are increasingly looking for is as-a-service consumption models. They're looking for, you know, kind of the ability to have a managed experience, if you will. Hey, I'd like to have my IT people do something else than just, you know, run around and configure and do stuff on hardware. HP, can you take all that stuff over? They're looking for the expertise to be able to say, oh gosh, I want to use Amazon, I want to use Azure, and I want to use my own data center environments. Which applications, which capabilities should I place where? How do I manage all that? How do I secure all that? How do I get transparency of financial? How much does it cost me to host in Amazon or Azure versus my own private cloud? What are my trade-offs? And all those types of things. And so if all we were doing was selling tech, okay, we wouldn't be really engaging correctly with our customers. And so GreenLake is really all about that notion of how do I provide a managed experience, right, with consumption-based pricing, right? And CTP is all about the expertise that allows our customers to take advantage of the best of an Amazon, the best of an Azure, and the best of their own data center resources in combination to deliver the outcomes that they want. I was talking to the CTP people, Chris, and you know, they said, I was asking them the cultural question of, well, how's it feel like to come into to Hewlett Packard Enterprise, which is, you know, kind of big company, 35 billion, and these guys are, you know, fairly small boutique consulting firm who fundamentally have most of their expertise in public cloud, okay? And I was like, well, what, you know, what was that experience like? And it's like, well, you know, like anything, there's a few bumps in the road, there's a few cultural issues, but in general, super positive, because, man, we're able to now fill out that missing piece, right? We were consulting with our clients on how to get the most out of Azure or how to get the most out of AWS, but now we can close the circle, okay? We can deliver expertise on that entire hybrid journey and really help these customers get the most out of all their IT resources, no matter where they decide that they want to do service delivery. And I thought that was a pretty interesting point. And so, you know, when you think about these kinds of things, we're clearly pivoting as a company from, you know, the years gone by where all the tech companies really thought mostly about the technology into really thinking about outcomes as a service and thinking about how do we really listen to what the customers are looking for, assemble the right technology, the right partners, the right services to really deliver on that outcome. As I said, I'm working a lot with blockchain, which is an emerging application. Gartner will tell you that of all the blockchain POCs, and there's plenty of them out there, very few have gone to production. Very few. Okay? Is that a technology problem? Is that a people problem? Is that a process problem? Yes, yes, and yes. Okay? And so what customers are looking for is a safe pair of hands and somebody who has the experience on not just the hardware level, not just the software level, not just on the application level, but on the process level with the right partners that they can engage with and get the job done. Ford Motor Company, as I mentioned, was out there about a month ago. Ford named us the Supplier of the Year, IT Supplier of the Year. Okay? Why? Because they're building next generation data centers for autonomous vehicles, and they need composable systems. They need the ability to compose just the right amount of IT resources for their trials and for their acceleration into those new business models. Intelligent edge, right? This is an interesting picture in that if you think about Aruba fundamentally cut its teeth on the mobile edge, right? And Gartner says that they're the wireless leader there, okay? But we also have the industrial edge, and there's a lot of synergy between these two, but there's some differences. On the industrial edge, you're dealing with the harsh environments, and you're dealing with industrial controls and sensors and different proprietary types of interfaces and ingest mechanisms, right? And so you've got to be able to think deeply about how do you get the data in, whether it's on a mobile phone, whether it's in an industrial PLC or whatever. How do I ingest it? How do I secure it as that data moves from edge to core, and as that data is in motion? How do I manage the data in the model between the edge and the core? Oh, I want to train using a high-performance cluster a particular TensorFlow model. I then want to containerize that model. I want to push it to 50 edge devices, okay, so that I have an entire software stack on the edge so that I can do computation at the edge. Oh, and that model needs to change every once in a while. So how do I update that entire stack, and how do I do all that automatically and as a service?
While maintaining power quality.
Exactly, right. Maintaining resiliency, security, and all those other kinds of things. So this is the landscape that we're working on, and the capabilities that we have across our hybrid IT estate with things like OneView and OneSphere and all the different storage, compute, and networking products, the capabilities we have with Aruba on their security and their policy-based enforcement and their beacons and their wireless technologies allow us to be in a very unique position in being able to engage with customers as they think about these outcomes. And then finally, memory-driven computing, right? As I said, we're working across the industry, across the silicon partners, across the software partners to really instantiate this memory-driven computing architecture as an industry standard, as something that the entire industry can build on for next generation computing. That means fast memory fabrics, that means task-specific processors, new types of software algorithms, and persistent memory, 3D crosspoint types of things. And we started our journey really thinking about the public sector, thinking about some of these government organizations who need next generation high performance computing where you can put memory on a fabric, where you can deal with acceleration. Path Forward was a DOE program that we're involved with today. We're involved with a couple of others that I can't talk about, but that's helping us fund some of this advanced development and some of this work. That led, of course, to things like the Apollo 70, which was just announced as a high-performance computing cluster based on the ARM technology, and a win that we had in the UK in basically providing these clusters to 3 UK universities for their high-performance computing environments. That then leads to things like our Superdome Flex, which today can access 48 terabytes of coherent memory, soon to be 96 terabytes, and we're putting a memory-driven computing fabric capability on that box, non-production sandbox right now, so that we can start to engage with customers in their in-memory and memory-driven computing journey, right? As they can start to try out their algorithms and see if they get a 10x, a 20x, a 100x performance boost. We're also conceptualizing next-generation data fabrics with Gen Z and photonics. I've got a presentation that we're doing the final edits on for some of our next generation photonic work with Antonio Neri, and pretty excited about all that. This stuff is real. It's not PowerPoint slides. These are silicon ASICs that are on their way to development, tape out, and next generation systems. Composable edge-based systems, composable rack scale systems. These are real concepts and real ideas that our business units are working on today based on memory-driven computing. So this stuff's getting real, okay? Now we still have to wait a little while. We'll wait for 3D XPoint. That'll be 2019. We'll be waiting a little bit longer for some of these next generation platforms. But in the background, we're working the ecosystems. We're working with the silicon providers. We're working with the software providers. We're working on fabric technology with the consortium of Gen Z and some of our competitors. And we're laying the technology and the ecosystem foundation for this commercialization. Last year or the year before, I can't remember when we did this, we basically talked about the machine prototype, or the machine 160 terabyte, 1200 core platform, right? That was the phase of us doing research and validation that these ideas have real skin in the game and are going to really prove themselves out commercially, right?
So, and on that note, if I can, I know it's incredible. We saw the presentation last year of the machine. We got to see what it did and how it did it, and it's phenomenal. Without someone utilizing it, how is that going to push? I mean, how many companies out there, or how many cases do you have of organizations that can actually utilize this now to help push and drive you, other than government contracts? And I mean, it's like it.
I have a very long list of customers who are waiting in line to basically utilize a Superdome Flex with that memory-driven computing personality on it to start the process of exploring, using their algorithms and their data, exploring what memory-driven computing can do. We've got a couple of instances of that. DZNE was one that we showcased last year. They got about 100x performance boost on their genetic pipelines. At this show, we're announcing Travelport, which is the search engine behind a lot of the airlines and hotels. They were finding with conventional computing that they were not delivering the search experience and the speed required, and if you don't deliver the speed, you lose the customer.
Can I get the exit row? Is that what that means?
Yeah, exactly. Can I get the exit row? Thank you. Oh, I missed it. Right. So there's a talk today about Travelport and the work that we're doing with Travelport, and one of the things we're announcing at this show is Superdome Flex with a memory-driven computing personality sandbox, and we're going to be delivering engagements with our PointNext service brethren to specific customers, and I've got a whole list of folks that are waiting in line for those engagements.
Yeah, just looking further out there, aren't we as humans memory-driven? And don't we have memory-driven personalities? So when does it intersect when you get to that point where you're almost the power of what our brains are today?
I'm already there. No.
Yeah. Some people look at me and say, yeah.
That's where his eyeballs start glowing.
Yeah.
Listen, I wouldn't even venture to wade into there. I think we've got a long way to go to think about man-machine kinds of orientations. But I will say this, right? One of the discussions we've had, think about an enterprise today, right? An enterprise that you're managing like a Hewlett Packard enterprise. What Antonio Neri would love to do is to see that enterprise breathe on a real-time basis. Be able to look at orders on a real-time basis, supply chain on a real-time basis, quality on a real-time basis. Okay? Can't do that today. Why? Because Hewlett Packard Enterprise, like most companies, has the data in how many places? 400, 800, 1,200 SQL databases, Hadoop lakes, and all kinds of things like that, and no way to keep that data hot so that you can look at real-time data, real-time actions, real-time intelligence. So the promise of memory-driven computing and the ability to pool huge amounts of memory is the promise of being able to solve problems we couldn't solve before, explore patterns and data that we never would have found in human interaction, but it's also this promise of being able to act with intelligence in a more real-time manner and watch that enterprise, watch that organization breathe. Now, this is going to take some time, and as I said, we're working on prototypes, we're working on use cases, we're working on silicon and software, but one of the things we are announcing at the show is that we're in the process of incubating a memory-driven computing practice and a POC engagement with select customers. That's going to be proof of concepts between HP Labs and our Point Next service organizations with program management and advisory services. And our Superdome Flex has a production personality in green, but it also has a sandbox personality that we're standing up and allowing engagement with customers. And that sandbox allows for you to look at putting memory on a fabric, huge amounts of that memory, being able to compose it, being able to utilize it for these new algorithms, these new applications like DZ&E, like Travelport, and the like. So we're pretty excited about that. And I know that you guys are going to get lots of slides, so this is my last one. You guys can clap, because you're going to be you're going to be really tired of slides by the end of 2 days. I'll tell you right. Let me just summarize here, right? Our strategy is really the intelligent edge and the hybrid IT, and how do we deliver an as-a-service experience, a secure, intelligent experience from edge to cloud. Now, in order to make that happen, we have our traditional compute, storage, network, software-defined, our management tools, and these kinds of things. But we also have increasing acceleration of our GreenLake as-a-service delivery and consumption, our predictive maintenance capabilities with InfoSight that allow us to be able to think of our own infrastructure in an IoT sense and be able to drive insights and deliver more uptime and more and better experiences for our customers. The enterprise data center fabrics, not just Gen Z, but moving from copper to photonics and these kinds of things. And then your software-defined and cloud storage capabilities. And I understand Milan Shetty is going to be talking to you guys next, and so you'll get a full download on some of our storage directions. We talked about this enterprise of the future that needed to have hyper connectivity and security, trust, and control, artificial intelligence and composition, right? And so we're working really now to think about how do we deliver on these promises of next generation architectures, next generation solutions and outcomes, not just with software-defined infrastructure, not just with security, not just with management capabilities, but thinking about this from a broader solutions perspective, from edge to the hybrid core, right? And making sure that we place data and the insights that you can derive from that data that allow you to run the the organization in a more effective way, place that data at the center of the architecture, at the center of the software, at the center of the management, at the center of the consumption, at the center of the experience and the outcome. That's what we're doing. That's a new Hewlett Packard enterprise. That's not something that everybody has wrapped their head around, okay? But we are engineering this company, okay, on this data-centric vision from edge to cloud with the notion that we have to help our customers on that journey as they continue to think about the best place to do IT service delivery and how to secure it and how to get the most out of it. Okay? Make sense? Any other questions?
Okay. Yeah.
When he gives me that look, I know
All
I've
right.
done something bad.
So where would you point these guys to? If they had a couple of things to look at on the floor, where would you point them to?
Well, you know, I've been so busy I haven't been on the floor a whole lot, but you know, I guess I would definitely, no, I mean I would definitely go to the Aruba and the Intelligent Edge stuff and really see what's going on there in industrial and in mobile IoT applications. There's a lot of really cool stuff there. I think, yeah. I would definitely check out OneSphere because I think what you see with OneSphere is you know, where customers really want to go, which is how do I get visibility, financial visibility, operational visibility from a hybrid estate. I would definitely take a look at some of the labs work that we're doing. We have a demonstration of Gen Z. We have demonstrations of some of our photonics work.
Where is that?
Labs? It's like in the middle, just before you can see it. It's pretty high up.
There's a studio, filming studio, and right in front of the filming studio, there's a big area of labs. They've got this big, almost like Lego playground. It's pretty cool.
So I would go down. You know, I would think about, you know, taking a look at all the intelligent edge stuff, taking a look at the hybrid IT stuff, taking a look at the advanced development and lab stuff, and looking at it within the context that I've just provided, and then saying, hey, is this stuff real, right? Is this stuff moving along? Is it compelling? Part of the reason why you're here and you're so important to us is not just that we want to influence the influencers, right? It's we need your feedback, right? We need your unvarnished feedback. You look at a lot of different companies, a lot of different technologies. You have a voice into our customers, and we're not going to do everything right. So we need you to understand our story, understand our directions, understand that we're changing and evolving to meet the needs of this next generation of opportunities and outcomes. But we absolutely need your feedback as to what you think's working, what you think's not working, and where you think we have gaps or opportunities. Yes.
Yeah, you hit all the major points, and being an engineer, I love this stuff. You know, talking about the security, talking about the AI, talking about all the accelerators, all this stuff. But there's still a disconnect that I see in the industry, and that is what I call the developer disconnect. You know, we say that we have open architectures, we have open software, we have open this, but the only people really developing those applications are the big OEMs because they have the cloud resources, they have the data. And there's a few companies out there, some are partners, some are competitors to HPE. What can or should HPE and or the rest of the industry be doing to overcome that developer disconnect? Because I completely agree that everything's going towards the intelligent edge. But that means we have to enable not just the OEMs, we have to enable the mobile developers, we have to enable the makers, we have to enable everyone to be able to take advantage of this technology eventually.
It's a great question. It is an amazing question. There's a couple of different aspects to this, right? Our focus is on, number one, championing industry standards. So we were the core mover and developer of the original redfish, swordfish work that was done and passed to the DMTF, okay, because we believed in software defining our infrastructure, and we believed that that needed to be an industry-wide thing, not just an HP thing. We are the mover and the shaker behind Gen Z and the establishment of a industry standard memory semantic fabric, because we have a fabric today, and we could have done a lot of the memory-driven computing stuff in a proprietary way, but that doesn't create an ecosystem, and that doesn't create these next-generation broad commercial applications that you talked about. We have an emerging sense of the importance and the criticality of engaging with developers, not just on those industry standards, but with our engineers, our content, our tooling, and the like. So one of the things that Chris does is works fairly heavily on our developer portal and some of our development tools and platforms with our open source teams and the like. And so we're a big believer in open source, particularly at the edge, because that's going to be very critical. And what we think about from a development perspective is how do we give them the content, the tools, the capabilities, the support that they need so that they can develop these next generation applications. Even this memory-driven computing sandbox is an example of that, right? But I think also, I actually see the industry moving more toward open APIs at all levels, at the infrastructure level, at the composition level, the cloud level. All of our work in that particular regard is around REST-based open APIs, and I see the industry moving in that particular direction. I see even Microsoft starting to adopt a lot of open source principles and starting to open up in things like this. It's a very different Microsoft than we saw many years ago. So I do see some progress. There are companies out there that still kind of want to lock you in and still want to, you know, once you get in, kind of beat you over the head and shoulders and say, you'll stay here with me forever, and those kinds of things. We're just not like that. We fundamentally believe in an even playing field, differentiation and innovation within industry standards, and there's danger in different architectural giants locking up particular portions of that. We fight against that every day, but that's a reality.
Yeah, one of the problems is everyone's fighting to be the data aggregator.
Yeah.
And, you know, we all talk about how the medical industry should change our lives and should be one of the early adopters of AI. But you've got all of the medical service companies out there hoarding the data, hiding behind HIPAA laws, which is bullshit. But, you know, saying, oh, we can't provide that. It's, you know, it's the HIPAA laws. No. They can anonymize that data. They can share that data. They can take advantage of that data, and they can allow developers to use that data. But, you know, that's the challenge.
Well, in fact, in the medical industry, we were talking to a couple of customers, and one of the customers had done vertical integration, right? So, you know, hospitals, pharmacies, the whole 10 yards into a vertical for just that reason, because they have all that data now, and they can deliver a better experience for the people who kind of in their thing. We were talking about this in the context of blockchain, because blockchain, if it's done right, is going to be an industry standard and is going to do a little bit of democratization of sort of data in that all of a sudden I'll be able to transact and exchange value and exchange provenance in a distributed, you know, way. So that then plays against that lock-in from a vertical integrator who says it's my data and I'm not going to share it with anybody else. They may find that the rest of the industry on blockchains is able to share just the amount of data that they think is population data, useful data, and the like, while keeping the data that they absolutely think is required, you know, in a safe place. These are big issues right now, quite frankly, and be nice if everybody you know, had the same opinion, but they don't, right?
Well, I have one more question for you, and then I'll let you go. But I love the slide where you talked about going from the cloud intelligence to the edge intelligence. But we have one more step after that. We have collective intelligence. Any thought on when we get to collective intelligence?
How would you define collective intelligence?
Where you have multiple intelligent things that all work together and define who's the decision maker. So if you got 1,000 cars on the road and they're all intelligent, one of them finally has to make a decision.
Yeah, so you're talking about swarm and hive and stuff like that, and mesh architectures to a certain extent. And it's a research topic. It's a research topic in our labs. It's important. When you talk to the automotive manufacturers, they think of it as in each individual car, I'm going to have this micro data center, if you will, and it's going to have acceleration and it's going to be processing lots of data, but then you're going to have a whole fleet of cars in a city, right? And that fleet of cars is going to need to interact with the smart city, right? So you go back to the standards and the openness and all those kinds of things. How do the automotive manufacturers who are collecting data as they drive around a city with their fleets, how do they share that data with the city of Chicago, who needs that data for traffic management and for all types of other types of things? And how does those fleets of cars actually share information between each of the cars, right? So these are areas of intense investigation right now, but we're going to have to wait a while. First, have to get one autonomous vehicle to work really well, and then 100 of them, and then 1,000 of them. But these are all big issues. I just don't have the answers to them.
I don't think any of us have that crystal ball. It's a great conversation.
Oh, it is. It's lots of fun too. Actually, lots of fun.
So we need to close this up. We're already a little over time. So thank you very much, Mark, for the conversation here. And join us all again at, what have we got? 11 o'clock is our next session with the HPE storage team here at HPE Discover.